Hey everyone, this is me Sachin. Welcome to my channel Redirect AI, and today we'll see how we do model selection using Python. Now before we start, why do we need this model selection? The model selection is a very important aspect of machine learning training part where we need the machine learning model with the best settings. All right, I'm just explaining it in very layman terms right now. Now, technically speaking, we train a machine learning algorithm to learn some parameters to minimize some loss function in a defined learning space. All right, that's about the definition of it. Now, apart from this, those parameters of that mathematical equation of that machine learning model, we do have some additional parameters which we call hyperparameters. Don't worry if you don't know what hyperparameters are. I've already covered that in a separate video. Please go check it out and you'll get to know a very good idea of what hyperparameters are. For the sake of understanding, I'll just call those hyperparameters as settings. So, we just need a model in the best available setting so that it fits our use case in a best possible manner, on a best generalized manner. All right. So that's why we have these model selection techniques, and going forward with the model selection, we have two popular techniques in model selection. One is grid search CV and one is randomized search CV, as you can see on the screen. Now, this grid search CV is basically a brute force algorithm or a cross-validation technique in which a user defines a set of variables and model is trained on various permutations and combinations of those variables or settings or hyperparameters, and that's how a model, the best model, is taken out or is selected. This is the highest performance metric, or maybe we can say the lowest generalization error. All right, now the second is randomized search CV, which is again works similarly like grid search CV, only in this one as well we prepare a grid, and this grid is different from grid search CV in only one aspect, that instead of user defined variables we use certain distributions of data like random or uniform or a normal, like this. All right, now let's understand the concept of cross validation and why this where the CV is coming from. Now, this cross validation is basically a technique where we have a data, we divide our data into training data and a test data. This training data and test data will be utilized in a different fashion. Training data will be used to train our model, test data will be used to test our machine learning model, that how it will perform on a real world, right? Now, coming to this part, cross validation, why this came into action. Earlier we had this train test split feature, and we can divide our data into three parts: training data and the test data. Test data we keep aside, we just use it to check the final accuracy or performance of our model, and we have this validation data set with us. Now, while making these sets, one thing that you can is, it is visibly clear as well as I've taken this picture from scikit-learn. This picture explains how the original data set has been divided into certain parts. Now, again, the original data has been divided. Now the learning space is getting smaller and smaller and smaller basis this divisions that we are doing. Now, I don't think this is the best technique. The best technique would be to train the data and then test the data on itself first on a certain part of it, right? So this is called kind of a cross validation technique. Now, what is this k-fold cross validation? So k-fold cross validation is an enhancement of cross validation, where instead of just randomly picking the data from the training samples to test the data before going to the actual test data, we make folds of data. Like in the given example, we make 5-fold of the data, and fold 1 will be used for the testing purposes, and fold 2, 3, 4 and 5 will be used for the training purposes. So that's how a model is trained. The various combinations of the models are trained on different folds. For example, it will go to split 1, then split 2, then split 3, then split 4, then split 5, and the final evaluation will be done on the test data. Now, while going through these different folds and different splits, we can have average accuracy or average generalization error with us, which can help us identify how our model is going to perform on the real world. And I think it's going to enhance the training as well of the model. So if you have very less data, or I mean, it just you can utilize this technique whenever you want to, because as in what I'm trying to say is this technique is really helpful in one aspect, that it will give you the best model of the all the available settings, and if you have very less data, you can make the best use of it to train your machine learning algorithm. Now going forward to the grid search CV part, we can import it from sklearn.modelselection.gridsearch.cv. So grid search CV is a brute force approach to model selection using cross validation. Specifically, a user defines a set of possible values for one or multiple hyperparameters, and then grid search CV trains a model using every value or combination of values. Then the final model with the best performance score, as we saw using the various folds and everything, is selected as the best model. Now in the going forward example, we'll just see an example, how we can implement grid search CV and how this is, affects the performance of the model. In grid search CV, we have primarily three main parameters. One is estimator, what estimator or the machine learning algorithm you're using in the backend, what kind of parameter grid you want to define. So it's basically a set of dictionary that we'll just see, and this scoring, that what kind of scoring we want to use to evaluate the performance of our cross-validated model. Now to implement grid search CV, we will use Spider IDE. You can use Jupyter Notebook or PyCharm if you are more convenient there. From sklearn, I'm importing linear model and datasets, which will give us our machine learning model and a sample dataset. From model selection, of course, the grid search CV. Grid search CV, you can see the definition in the yellow box here, and it's like a quick documentation. I really like this feature in Spider. After loading the libraries, we will load the data. Let me just run it quickly. All right, you can use F9 to run it. To load the data, we will use the iris dataset, which is used for classification and will be used by our logical regression model. From datasets, we can load iris. In iris object, we have certain features, like in iris.data will give us features, iris.target will give us target. While loading iris, you can use this parameter called return xy equal to true, and you can unpack values directly into features comma target. Now let's call our logical regression model. So we will just use linear model dot logistic regression, and we'll just pass it on and then as an empty object. We're not passing any parameters or hyperparameters because we will optimize them separately in our grid search. So we're using the hyperparameter penalty like L1 and L2 regularization. L1 is for lasso, L2 is for ridge. We'll cover that later as well. Don't worry about it. Just understand these are certain hyperparameters. Second hyperparameters is C. It's like a regularization penalty, and don't worry if you don't know what C and regularization mean. We will cover them in next few videos as well. So C is basically strength of regularization, just for the sake of this video. Now we will just pass these parameters in a dictionary. Always pass these hyperparameters grid in a dictionary. Now we will initialize our grid search. In our grid search, you see we have various parameters, estimator, parameter grid, scoring, and most of them have been set by default. So let me call the useful ones that we would explore right now. Estimator logistic, parameter grid parameters. Yes, refit equal to true, definitely. Verbose will give us the messages on the right side in console, that how model is performing, what set of algorithms it's choosing, and cross validation is 5. See, it's not k-fold, it's just simple cross validation as 5. Now we'll just call the grid search.fit on features and our target. Let me run it. Okay, after some iterations, we see for different hyperparameter values like C and the combination of penalty. So we have different scoring parameter has been evaluated, and basis all the all the parameters that have been fiddled with, wherever we have the least generalization error or the best performance, that would be our best estimator and can be called using the best estimator. So the best model and the best estimator, we'll just call, hold on. All right, let me just correct it. Yeah. So always refer the documentation because syntax issue can sometime arise. Always, keep the documentation handy with you. Now for the best estimator, we see this value of C 7.74, and basis the get params, we can get the different hyperparameters, which is like a dictionary, and we can call different hyperparameters. Like I'm calling penalty, and likewise, let me just call the another hyperparameter C, and I'll have the hyperparameters, which are the best tuned to this logistic regression given the iris dataset. Now let's use it for prediction. We'll just if we use the predict attribute here, and grid search CV will retain a model using the best hyperparameters, and using the certain libraries you can dump the model as well and use it again for the future use or maybe to deploy it in production. Now we've got some prediction like 3 classes 0, 1 and 2 for 3 different classes that we have in iris dataset. So right now we're not seeing at any evaluation score, but let me just try one thing. Let me just show you if I can show you the accuracy. Let me just take the sum of all the matches. So wherever we have true, I think that would be a right prediction. Okay. Let me just correct it. All right. Let me just see how many trues in total. Okay, we have 147. All right. So we'll use it to divide it by length of our target variable, which is like 190, 98. All right. So there could be a possible case of overfitting here, but we've got 98% accuracy. Now another technique is randomizer CV, as I just mentioned. Randomizer CV is just like grid search CV. In grid search CV, we used user-defined set of hyperparameter values to search for the best model according to a score function. And in randomizer CV, we use a more efficient method than grid search CV, brute force search, to search over a specific number of random combinations of hyperparameter from user supplied distributions. Now these distributions can be normal, uniform or random. So we'll just see how we can implement it using scikit-learn, and let's see how it works. Now earlier we used grid search CV on a user defined set of hyperparameter values. Randomizer CV is again imported from model selection only. So I'll just make some changes in the available code. So you see we have this functionality in Spider, and you see the parameters are almost the same. I really like this feature of Spider. If you're using Azure notebooks or something like Jupyter Notebook, keep the documentation handy on scikit-learn. That's my suggestion. Now one parameter that we have changed is param distributions. Actually, instead of parameter grid, we will use parameter distributions, and these distributions are either going to be normal, uniform or random. So this is the main differentiator between randomized search CV and grid search CV. Instead of user supplied distributions, we will search over a specific number of random combinations instead. All right, let me just quickly make this code work. In case I'm going way too fast, I've increased the speed of the video. You can just reduce the speed 2.75, and that way you can code along if you want. So I'll just use the uniform here. We'll randomly take 10 sample values from a uniform distribution, and I'll import it as well. Right, so we are actually defining a uniform distribution between 0 and 4, and we need 10 sample values. So you can see you have this uniform continuous random variable definition with you. All right, what happened? Let me check, something is not right. Let me correct it. All right. Okay. So we need to pass. I'm just passing the parameters. Maybe it just behaves like this sometimes. Okay. This is done. This is done. What else? Yeah. So we'll just fit the best model, and one more thing that I would like to add here is iterations. So I'm increasing the iterations for n iter. All right. This is done. This is done, and this is done. All right, let's see how the parameters are. Model has been trained. So the best penalty is L2 again. Let's see the value of C. So see, we have different set of values. So one model can be an overfit case which has converged really soon, or maybe the iterations were very low. So it's always healthy to increase the iterations, but not very much. We'll see this trade-off in another tutorials as well, that how this impacts the training ability of a model. It's called debugging a model. So this is done. We have predicted. We implemented Randomizer Cv. See, sometimes we think increasing the sample space would help us train the model better, but it can lead to overfitting. Don't worry, we'll understand this trade-off in another video. So we implemented grid search and randomized search. All right. So we learned how we can implement grid search CV and the randomized search CV in a real-time working project, and how we can select the best machine learning model out of it. Apart from it, we also learned what is cross-validation is, and what is k-fold cross-validation. One debrief that I would like to add here is, guys, please try to implement this on your own. Play around with the code. Everything that I mentioned here is open source. I've already given the references. Maybe you can find it in the description or at the end of the slideshow that I would be sharing. And please go around, play with it. If you have any more questions, please Google them out first and then come to the comments. I think while you are searching on your own, it will give you a more holistic understanding of a new concept. And apart from it, since it's a part of quick implementation series, please don't get disheartened if you don't understand few of the concepts. I'm not starting from scratch, but I'm trying to cover the majority basics in a quick implementation manner, and how you can just quickly see this video, understand the quick implementation, and apply that in real time in your projects. Lastly, if you have any more questions, please leave in the comments. Please like and subscribe. And if you are facing some real challenges in your real-time projects, please do connect with me on my personal email, and I'll be happy to help you out. I'll see you in the next one. Stay tuned.